Hello, in this video, we're going to talk about special right triangles. In the previous lesson, we looked at how to find the missing side in a right triangle using the Pythagorean theorem, a squared plus b squared equals c squared. There are two special types of right triangles where the ratios of the sides are proportional to each other. And those special right triangles are 45, 45, 90 triangles and 30, 60, 90 triangles. And what's cool about these triangles is if you know just one of the sides, you can find the other two, which isn't the case with Pythagorean theorem. Pythagorean theorem, you need two sides to find the third. But for a special right triangle, you only need one side, and then you can find all of the others. We're going to start off with 45, 45, 90 triangles. In a 45, 45, 90 right triangle, since the two angles are the same, we know that the sides that are opposite those angles are also going to be the same. So both of the sides opposite the 45-degree angle, we call those the legs. And the legs are congruent. So they're both the same value. And then the hypotenuse is going to be the square root of 2 times whatever the leg is. So in our picture, the leg is the A, and the hypotenuse is A times the square root of 2, or leg times root 2. Now let's look at some examples. We want to find the missing side lengths in each of the 45, 45, 90 triangles, and we're going to leave our answers in radical form. First, let's figure out where the hypotenuse is. I always do that one first. The hypotenuse is across from the 90-degree angle. So here's the hypotenuse, and then the other two sides are the legs. Remember that the legs are congruent in a 45, 45, 90 triangle, so we know that n is going to be 11. To get the hypotenuse, we can use the ratio where the hypotenuse in a 45, 45, 90 triangle is equal to the leg times the square root of 2. So here that means the hypotenuse, the m, is equal to the leg, which is 11, times the square root of 2. So now we have both of our missing sides. In this next triangle, I'm going to again start by labeling my hypotenuse across from the 90, and then the other two sides are the legs that are congruent. So right away, we know that B is going to be 4 root 3 because the legs are the same. And then the hypotenuse, the A, is equal to the leg times the square root of 2. Well, here our leg is 4 root 3. So the A is going to be 4 root 3 times root 2. And when you multiply two radicals together, root 3 times root 2 is just root 3 times 2. So you can combine the roots together, but you keep the 4 outside. And then 3 times 2 is 6. So A is going to be equal to 4 radical 6. Here's another example. We have a 45, 45, 90 triangle, and in letter C, the side that is given is 7 root 2. Notice that the hypotenuse is the x, and the other two sides are the legs. Well, right away, we know the legs are congruent, so we know that y is going to be equal to 7 root 2. To get the hypotenuse, the x, we're going to use that relationship where the hypotenuse is equal to the leg times the square root of 2. So here the x is going to be 7 root 2 multiplied by root 2. And once again, when we multiply two radicals together, we can do 2 times 2 under the root, and that's radical 4. And notice that the square root of 4 right here is a perfect square. The square root of 4 is equal to 2. So this value right here, we can actually just change it to 2. So I'm going to have 7 times 2. So x is actually just 14. So what you'll notice is anytime you multiply a root with itself, the root's going to go away. So for example, this isn't something you need to add to your notes, but just a random example here. If we take root 5 times root 5, well, 5 times 5 is 25, but the square root of 25 is a perfect square. It's equal to 5. Root 7 times root 7 is root 49, but the square root of 49 is just 7. So when you multiply a root by itself, the root goes away. That only works, though, if the two radicals are the exact same. If they're different, then it doesn't work. All right, let's try another one here. So in letter D, I have the hypotenuse this time is 8 root 2, and then we're missing the legs. We know that whatever they are, they're going to be the same. U is equal to V. And we have that relationship again where the hypotenuse is equal to the leg times the square root of 2. Let's substitute in what we know for the hypotenuse. The 8 root 2 has to equal the leg, and the leg, I'll just use U, root 2. Well, if these two things need to be the same, and we need to get the U by itself, let's just go ahead and divide each side by root 2. And what happens there is that the roots just cancel. Root 2 divided by root 2 is just 1. So we actually have U equals 8. And V is going to be the same, so V is also equal to 8. And then if I go the other direction now, it makes sense because the hypotenuse is just 8 times the square root of 2. Here's two more examples of 45, 45, 90 triangles. This time we are given the hypotenuse again, but there's no root 2 in it. I'm still going to kind of set it up the same way. The hypotenuse is equal to the leg times the square root of 2. The legs are the y and the x. So let's just pick one of those letters. I'll do x. So 6 is equal to x times the square root of 2. Now we need to divide by root 2 to get the x alone. I'm going to undo that multiply. And then we're just going to leave our answer in radical form. So I'm going to leave it as 6 divided by the square root of 2. And we know that if x is 6 divided by the square root of 2, y is also going to be 6 divided by the square root of 2. Go ahead and try the next example on your own. Please pause your video now, and then when you hit play, I will have the answer posted. Please pause. All right, here is your solution. The hypotenuse is 9. That's equal to the leg times the square root of 2. So we just divide each side by root 2, and that makes m and n both equal to 9 divided by the square root of 2. Next, let's practice some 30, 60, 90 triangles. In a 30, 60, 90 triangle, since all the angles are different, all the sides are going to be different. The longer of the two legs is always equal to the square root of 3 times as long as the shorter leg, and the hypotenuse is twice as long as the shorter leg. So in our picture here, the short leg, which is across from the 30-degree angle. Remember, the smaller side is across from the smaller angle. So the 30-degree side, if I go directly across it, that's my short leg. In the picture, that's the B. Well, the long leg, which is across from the 60-degree angle, the long leg is going to be the short leg times the square root of 3. So in our picture, it's b root 3, but in general, the long leg is the short leg times root 3. And then the hypotenuse is twice the short leg. So 2 times b, or in general, 2 times short. It's always helpful to label your triangle first. The short leg is across from the 30, the long leg is across from the 60, and the hypotenuse is always across from the 90. So let's go ahead and try some examples now. I'm going to begin by labeling my sides. I like to start with the hypotenuse, which is across from the 90. And then the short leg is across from the 30-degree angle, which would be this one right here. So there's my short leg. And then my long leg is across from the 60-degree angle. That's the N. Here, since we have the short leg, we can actually start either by finding the long leg or the hypotenuse. It doesn't matter which one we do. I'm going to start with the hypotenuse here. If you go back to your theorem, the hypotenuse in a 30, 60, 90 triangle is equal to 2 times the short leg. So here, with our short leg being 4, the hypotenuse, the M, is just 2 times 4. It's double the short leg. So M will be equal to 8. Now we can go ahead and do the long leg. And in a 30, 60, 90 triangle, the long leg is equal to the short leg times the square root of 3. So that means the N is going to be our short leg. So I go back to my 4 and then root 3. And now we have all the sides in our 30, 60, 90 triangle. Problem B is similar in that we have the short leg, 3 root 3, and we need to find the hypotenuse and the long leg. Doesn't matter which one we start with because both formulas involve the short leg, so I'm going to start with the hypotenuse again. Hypotenuse is twice the short leg, and the short leg here is 3 root 3. So for 2 times 3 root 3, since 2 and 3 are both outside the radical, you can multiply those together. 2 times 3 is 6, and then you're going to keep it as root 3. So x is 6 root 3. Now we can go ahead and do the long leg, and the long leg is just the short one times root 3. So it's a good idea to write out the equation and then substitute your values in. So long leg y equals the short leg, so back to that 3 root 3, times root 3. And when we multiply these together, remember that a root 3 times a root 3, since those are both under the radical, we can combine those. 3 times 3 is 9. So 3 root 9, if I do square root of 9, is actually a perfect square again. Square root of 9 is exactly 3. So we actually get 3 times 3, 9. So that's another example where when you take a root times itself, the root cancels out. Root 3 times root 3 is just equal to 3. And then the 3 times the 3 makes the 9. You could also type that in your calculator and it would give you 9 as well. In our next triangle here, this time we don't have the short leg, so this is going to be a little more challenging. You can see in triangle C here, we have the hypotenuse is 12, the long leg across from the 60 is the x, and the short leg, which would be across from the 30-degree angle, is the y. Now everything is based off of the short leg, so we need to figure out what the short leg is before we can do the long leg. When you don't have the short leg, you want to use the formula for the one that you know. So we know the hypotenuse. So I'm going to use the hypotenuse is equal to 2 times the short leg. That means 12 is going to equal 2 times y. And now to solve for y, we can just divide each side by 2. And that is 6. So y will be equal to 6. So y is half the hypotenuse. Right? Notice if I go back and take short times 2, I'm back to 12. 6 times 2 is 12. Well, now that we have the short leg, now we can go ahead and calculate the long leg, because the long leg is just the short leg times the square root of 3. So the x is going to be that 6 multiplied with the root 3. So solution, 6 root 3, and we have our missing sides. D also has a hypotenuse here, and we're missing the long leg and the short leg. So because I have the hypotenuse, I have to start with that one. So hypotenuse is the short leg times 2. So the 4 root 3 is going to be equal to 2 times the y. Again, we have to divide by 2 to get the value. Notice that the 2 is not a radical, so we can actually put these two together and just divide them. 4 divided by 2 is 2. So we'll just change this to 2 root 3, and that's our y value. And now that we have the y value, the short leg, we can use that to figure out what the long leg is by knowing that the long leg is the short one times root 3. So here, the x is going to be the short leg of 2 radical 3 times radical 3. Recall that when you take a root times itself, remember how you get that value. Root 3 times root 3 is just 3. Because square root of 9 is 3. And then if we do 2 times 3, well, that is 6. So our x will be equal to 6. For our final two triangles here, we have the hypotenuse missing and the short leg is missing. Notice that that 6 root 3 there is the long leg. So now, since I don't know the short leg, I have to start by using what I do know, the long leg. So in any 30, 60, 90 triangle, the long leg is just the short one times the square root of 3. So the 6 root 3 has to be equal to v root 3. Well, they both have root 3's in them, so when I divide by root 3 on each side, that's going to cancel out on both sides, meaning that v is just 6. And now that we know the short leg is 6, we can use that to find the hypotenuse. Hypotenuse is just twice the short leg. So I'm going to do u equals 2 times 6, which means u is 12. Next, we have another triangle where we have the long leg given to us across from the 60. We're missing the hypotenuse across from the 90, and we're missing the short leg. So let's go ahead and use what we know, which is the long leg. We know the long leg is equal to the short one times the square root of 3 in a 30, 60, 90 triangle. And here, the 12 then is going to be equal to the short leg, so n root 3. We need to get that n by itself, so I'm going to divide each side by root 3. And when we do that, we get n equals 12 over root 3. And you can leave it just like that in radical form, 12 over root 3. Now that we have our short leg, we can finish up by finding the hypotenuse. Hypotenuse is just twice the short leg. So here the m is going to be 2 times 12 over root 3. A 2 is like a 2 over 1. So when we multiply our fractions together there, 2 times 12 is 24. And 1 times root 3 is just root 3. So that means that the m is going to be equal to 24 over root 3. So we've now seen several examples of 30, 60, 90 triangles and several examples of 45, 45, 90 triangles. I am going to have a second video for this section that goes over the mixed review, where the triangles are mixed up. Some of them are 45, 45, 90, and some are 30, 60, 90. So if you'd like to see those examples, check out the day 2 video. Thanks for watching. Bye.